I'm Jeff Ralston with Ralston Eco Homes, and we're in Atkins again, in the basement of one of our duplexes. And I'm here with Adam Welch. Adam owns Vertex Home Performance, so he's the gentleman that designs our HVAC system for us and also is able to test our system. And so we're going to talk today about commissioning the equipment that we've installed. What is commissioning and why do we do commissioning?
Sure. Commissioning is the last step in making the system perform the way that it's designed to operate. Items like airflow, making sure the airflow is correct, making sure refrigerant charge is properly done so that the right amount of BTUs are put into the airstream. And then the last step is balancing, moving the air from the ductwork system to the parts of the house that you need the heating and cooling.
Now, the thing I didn't understand at first is that, I mean, surely this equipment comes from the factory working the way we want it to, right?
You'd like to think so, but the last step, yeah, it is up to the mechanical contractor or a commissioning agent to do the fine-tuning or adjustments to make it work the way it's supposed to.
Yeah. And we've done all the other things I can think of to try and make this house and the equipment as efficient as possible. We've done duct sealing, which we've talked about. We've sealed everything we can think of, and we think this is a super high efficient unit, but this commission is going to confirm that it is, or that it's performing at its maximum efficiency. Is that right?
Yep.
So that we're not only that this is producing the airflow we want or we're expecting, but it's also delivering it to the rooms the way we want to.
You definitely want to get the heat where you're wanting to be the most comfortable, which is in your main living spots. Right. You don't want it all in the basement where we're not occupied, I guess, here.
So Adam, just explain to me what you've done here, because you've drilled some holes in my system. So we have a hole here.
Yeah, so this is going to take a static pressure measurement.
Okay.
It's going to give us a baseline for using our flow grid, which is a tool that goes into the filter rack.
Okay.
And it measures the actual air through the system as it's operating.
All right, so this tube that's going into that, this is the return here.
Correct, yep.
Okay, you're gonna be able to measure that flow.
Correct.
Okay, so what you're telling me then is the amount of flow through the system is 670 or something. So what we've talked about so far is that 670 might be a little bit low, that the unit should be more in the 700, 750 range per the manufacturer's recommendations. And then the way you would adjust that is by changing the circuit, the way that the wires are connected to the fan, so that it runs at a higher speed.
That's correct.
Adam, again, I'm not an expert at these kinds of things, but we're delivering we're hot outside right now, so we're delivering cold air to the house, and then we're returning warmer air to the system so that it can cool it and then send it back. And so there's going to be a differential in air temperature between the return air and the air that's going out to the house. And on a system that's working properly, the differential in those temperatures is what?
It should be anywhere from like 18 to 20 degrees.
18 to 20 Fahrenheit.
Yep, from what's coming into the return and what's coming out of the supply side.
So we put a hole in the supply part of the system, and we're measuring the temperature here.
Correct. And we're hitting about 55 degrees.
So the return air is 68, which is what we predicted it would be, because the house is currently at 70 degrees. And then the air that's going out to the house is 55 degrees. Yep. So that's the differential we would expect.
So
maybe even a little low.
A little low, yep. So if we can get that airflow back up, adjust refrigerant, I think we should be good.
Okay, great. Now we're going to look at the individual ducts to look at the airflow at those, so we can balance the system. Yep. And what do you have here? This is kind of funky.
This is a flow hood, measures the air coming out of the vents. So we'll see what we've got.
So that just sits over the register or the duct, and then it's going to measure the flow coming out of that.
So we're going to be able to see the flow, and it looks like we're getting about 86 CFM.
As part of designing this system, we would have given a value to each register. So this register would have been designed to provide a certain amount of flow. And then what if this is off? So then there are two ways to do this. We could have installed a damper at the time of construction, But if we're coming into a situation where a damper has not been installed, then this is a retrofit.
Yep.
Okay, so that damper is sitting inside the duct. And then you're going to be able to open and close that to restrict flow from the duct.
We always measure with the register back in.
Yep, because that's the actual situation that it'll be in. So you've restricted the flow there. Looks like it's 55, 54. Okay, we've got the air handler working the way we think it should work, and now we've gone throughout the house and balanced our registers by putting in dampers and getting those set up the way we want them. And then the third place that we're going to make sure that the system is working properly is outdoors here. We're going to work with the refrigerant. So what are you looking at? What are you going to measure out here on the refrigerant to make sure it's working properly?
Yeah, so we use these digital set of gauges here. We're going to measure the pressures of the liquid and suction line on the air conditioner, and also the temperatures, and then compare it to the manufacturer's data. And then if it needs any adjustment, we'll adjust it to the right pressures, and then we'll get hopefully better temperatures inside than what we have now.
And the way you adjust those pressures is by adding refrigerant, adding or removing refrigerant.
Yep, that's correct.